Okay guys, so the next one I'm going to go over is number 7. This is kind of a confusing one, but that's because of the way it's written. It's meant to be written a little tricky, but it's really not that bad. So the question reads, a fixed volume of a gas has a pressure of, so right there we know it's pressure, 1 of 942 millimeters of mercury, mmHg, okay? And it says, what will the pressure of the gas be? So there we know we're looking for pressure 2, right? So that's our unknown. We don't know how much that pressure will be. But then here's where it gets tricky. It's because it says the temperature is halved. So that means that there's a temperature 1 and a temperature 2. So what I want you to understand here is that the actual number for the temperature does not matter. It doesn't matter if we're looking at the temperature of 1000 to 500 or the temperature of 50 and 100 or 200 and 100, as long as temperature 1 is twice what temperature, that means by temperature is halved. So for our purposes, we're going to go ahead and write the number in Kelvin to be 100 Kelvin, okay? And so if it's saying the temperature is halved, it means the temperature has to be 50 Kelvin, right? So now, and again, these don't matter. You could have picked 400 and 200. You could have picked, 200 and 100. You could have picked 150 like I did, or 50 and 25, as long as it's a half, okay? Because all we want to know is what's happening to the pressure when it halves. Now, the extra other step here is that this is in millimeters of mercury. We want this to be in atmospheres, okay? So that's the first thing. We need to convert 942 millimeters of mercury into atmospheres. Okay? So we need ATM right there. Now, in order for this to work, on the bottom we should have mmHg on the bottom. Now, I told you before we left, and it should actually be in your conversion sheets from way back at the beginning of the year, but the conversion from atmosphere millimeters of mercury is always 1 ATM is equal to 706 millimeters of mercury. Okay? So at this point, what you do here is these units cancel, like any other conversion we've done, and you take 942 and divide it by 760. When you do that, you should end up with a number of 1.24 atmospheres. Okay, so that is now our new pressure 1. So we can kind of cross that out, and our atmospheres now is 1.24 ATM. Okay, so now we have to look and see which law is this, right? So it's got pressure and temperature, which means if we went to pressure temperature is going to be Gay-Lussac's law. So that's Gay-Lussac's, which is written like this. It's meant to be T1 times P2 is equal to T2 times P1. Okay? So you have some of the numbers already. Now we have to figure it out. So the we're looking for now is going to be P2. That is our unknown. Okay, so you then plug in the rest of the numbers as we do in the rest. So our temp 1 is going to be 100 Kelvin. Our pressure 2 is unknown. Okay, that's our X. Temperature 2, we decided it was going to be 50 Kelvin because it's halved. And our pressure 1, we calculated that one already. That was 1.24 ATM. Okay, so now at this point, what we have to do is just do the math. We figure out the math. So this would be 100 X is equal to 50 times 1.24. So 50 times 1.24, and I got a total of 62 on that. Did that right? Yeah, double did 62. So now we need to solve for X, and that is a simple thing of dividing both sides by 100. So that's leaving X over here, and 62 divided by 100 should be the decimal of 0.62. And what is it working for? Back, it's pressure, and the unit of pressure is ATM. So this is 0.2 ATM, and there's our answer for number 6. Okay, so hopefully that made a little sense, but again, much easier than it